Hello, Luke. Welcome to Lesson 43. So today we're going to be talking about the least common multiple, and then we'll also apply that to algebraic expressions. So let's get started. Let's talk about multiples first. Before we talk about the least common multiple, or the LCM, as it is sometimes referred to, let's talk about what a multiple is. That's kind of important. So, what is a multiple? A multiple is the answer to a multiplication problem which involves a given factor. All right, now I know that sounds confusing, but let's just say we have the number 3. And I want to know, what are the multiples for the number 3? Well, the multiples for the number 3 are all of the answers to the multiplication problems that have 3 as a factor. Another way to think of it is a multiple is any number that is evenly divisible by 3. All right, so if we had to list them, we would say, well, let's start with a multiplication problem that involves the factor 3. So we'll start with a 3, and we'll multiply that by a 1. So that's a 3. So 3 is a multiple of 3. All right, 3 is evenly divisible by 3. Or another way to think of it, 3 is the answer to a multiplication problem using this 3 as a factor. So what are some other multiples? Well, we've got 3 times 2. Let's just increase that factor up by 1. And we get 3 times 2 is equal to 6. So 6 is a multiple of 3. And I could keep going, right? I could say 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. It's just the 3 multiplication tables, right, that you've learned many, many years ago. So this would just keep going, just keep marking up in increments of 3, and so on and so forth, right? So all of these answers listed here, they are all multiples of 3. And the multiples, the list of multiples, would continue on indefinitely. It would go on forever, right? Okay, so that is what a multiple is. All right, so what's a common multiple? Well, a common multiple is when we have 2 numbers that we're looking at. So maybe we'll choose a 9 here. All right, and we ask ourselves, what are the multiples of a 9? Well, we could do the same thing. We could create a little table here and just show all the multiples of 9. So it's, using 9 as a factor, we would have 9 times 1 is equal to 9. 9 times 2 is equal to 18. And this would keep going, right? We would just keep marking this down. The next one would be a 27, and then a 36, and then a 45, and then a 54, and then a 63, and then a 72. And we would just keep going on and on and on and on forever, right? So all of these would be multiples of 9. Again, all a multiple is just a number that, in this case, this 9 can go into evenly, or just think of all the answers to all the multiplication problems that involve 9 as a factor. Okay, so maybe let's do one more. What about 12? All right, if we wanted to find the multiples of 12, we would just kind of go through our multiplication tables. So we'd have 12 times 1, which would be 12. 12 times 2, which is 24. And then we could just keep going, right? We'd have a 12 times 3 is 36. 12 times 4 is 48. And this would just keep going on and on and on forever, right? Okay, so that is how we find multiples. But now what about the least common multiple? Well, to find the common multiple, we're looking at these 3 numbers in this case, and we're asking ourselves, which multiples are common between the 3 numbers? So this one has a 9. This 3 has a 9. That's a multiple of 3. 9 is also a multiple of 9. So 9 would be a common multiple between these 2 numbers, 3 and 9. But it's not a common multiple between the 12 as well, because this does not have a multiple of 9. So if we go a little higher and look for the next common multiple here, well, we see that this one has an 18 and this one has an 18. But again, 12 does not have a multiple of 18. So then we keep moving on, and eventually we get to this 20. Let's see. Well, actually, we have to go even one more here. Let's go 3 times 11. Oops, is 33. 3, oh my goodness, 3 times 12 is 36. And we have to get to that one. So if we keep going, we eventually hit this 36 right here. And we recognize that, oh, this one has a 36 and this one has a 36. All right, so all three of them have a 36 as a common multiple. And that is the smallest one that we can choose, which is in all three of them. So that is the least common multiple. So when we have these three numbers, the least common multiple is going to be a 36. Okay? Now, this should seem really familiar to you because you've done this many, many, many times when you're trying to find the least common denominator, the lowest common denominator. So if I had, 1/3 plus 4/9, the first thing you would do here is try to find a common denominator. And to do that, you would use the least common multiple. In this case, you would recognize that the first number that both 3 and 9 can go into evenly is a 9. So you would change the denominator to a 9, and then, of course, you'd have to change the numerator accordingly, and this is how you would end up adding this problem. Right? These fractions. So you've done this many, many, many times. This should just be a review. All right, but we're kind of laying out what it means to have the lowest common multiple. Okay, so let's now just talk about how difficult this can sometimes be. As maybe you've noticed before, sometimes we might not have lower numbers like a 3, 9, and a 12. We might have larger numbers, in which case it's a little bit more difficult to determine what is the least common multiple. Let's say in a scenario where you're trying to find the lowest common denominator, for example. It's going to be a little bit difficult. So let's talk about another method to find the lowest common multiple that doesn't involve all of these tables here with all these values and all this multiplication going on. All right, there's an easier way to find the lowest common multiple. So let's just talk about that. I think we're going to do it over on this side here. We'll try to fit all this onto one page. So let's talk about easier method. Easy method to find the lowest common multiple. Okay? All right. And it involves factoring, which you've been doing a lot of, so that should be pretty familiar to you. So if I have, and we'll just use the same numbers, 3, 9, and 12. The first step is to take each of these numbers that we're interested in and factor them. All right? So if we take the 3, well, the factors for a 3 are just a 3. And the factors for a 9, well, I mean, we could do this, right? 3 and 3. We should really be able to do that in our head, but let's just make it obvious here. It's 3 times 3. The factors for a 12, again, we'll just make it obvious, is 2, which is 6, 2, which is a 3. So we have a 2 times 2 times 3. Okay. So we've factored all of our numbers. That's the first step. Now, the second step is to look at these factors that we have now and just determine what numbers are being used in all of these factors. So what numbers do we see in these factors? And you might say, okay, well, we see a 3. Maybe I'll just put a box around that. We see 3s. And what else do we see? We see 2s. Okay, we see 3s and we see 2s. There's nothing else. There aren't any 5s. There aren't any 7s, 11s. There's nothing else here. It's just 3s and 2s in different quantities for each of these three numbers. Okay, so now we have 3s and 2s. That's what we're dealing with. The next step is to determine the greatest number of 3s that are used for any one number. All right, so this first number, we only used 1 3. The second number, we used 2 3s. And the third number, we only used 1 3. So the most 3s we used in any of these numbers is 2. So we are actually going to use 2 3s. All right, we're going to use 2 3s because that's the most that was used in any of these three. All right, 2s. Well, this one doesn't have any 2s. This one doesn't have any 2s. This one has 2 2s. So the most 2s we see in any one number are 2. So we're going to use 2 2s as well. Okay, now we're going to take all of these factors that we've kind of pulled out from these three, and we're going to multiply all of them together. And if we have 3 times 3 is 9, 9 times 2 is 18, 18 times 2 is 36. So 36 is the lowest or the least common multiple. All right, see how easy that was? We didn't have to do any of these tables over here. All we had to do was factor them, determine what numbers were used in those factors, and then take the greatest number of those numbers that are used for any one number. That's a lot of that probably didn't make any sense. So, but I think you get the point. We're taking the greatest number of 3s, for example, that were used for any one of these numbers up here for their factors. Okay, so let's try this method on some larger numbers. Let's say we have 15, 81, and 500. Now, I think you can appreciate the fact here that trying to find the lowest common multiple using our old technique would be very tedious. I mean, I'd have to find out, the 15, I have to go through my 15 table, and then my 81 table, and then my 500 table, and then find the lowest common multiple in those tables. So that'd be a real pain. But instead, in this case, let's do it with the new method, the easy method. And to do that, remember the first step is to factor it. So if we factor this 15, we end up with a 3 and a 5. If we factor this 81, we're going to end up with a 3, which can go into an 81. How many times? 6, 27 times. And then a 3 can go into a 27 9 times. And then a 3 can go into a 9 3 times, right? And then we have 500. Well, 2 can go into 500. That'd be 250. 2 can go into 250. That'd be 125. 5, well, yeah, 5 can go into 125. Well, let's see, 5 can go into 12 twice with the remainder of 2. So let's say I have 25. 5 can go into 25 5 times. And there we go. We've got them all factored. Okay. Now we talk about what numbers are we dealing with in these factors. Well, I see 3s. Maybe we'll start with the smallest number. What do we have for the smallest number? That way we kind of keep it organized and we won't miss any. So if we start with a 2, I do see 2s, right? I see 2s in this last one, and that's actually the only one with 2s, and it has 2 of them. So the largest number of 2s that we can pull out is going to be 2. So we have 2 times 2, right? Now let's go up to a 3. And we have a 3 here, and then we have 4 3s in this one, and nothing in here. So the greatest number of 3s is 4. So we can multiply this by 4 3s. Okay. Now we don't have any 4s, obviously. That wouldn't be a prime number. We go up to the next prime, which would be 5. We have 3 5s in this one, and that's the greatest number of them. So we have 5 times 5 times 5. So the answer to this nasty looking product, that is going to be our greatest common multiple. So let's multiply it out. So we have 2 times 2, which is 4. 4 times 3, which is 12, right, to this point, right? And actually, we'll just make that up into a 12. And then I have 3 times 3, which is 9. So we have 12 times 9. And then we have times that by a 3. And then we have 3 5s, which would be 5 times 5, which is 25. 25 times 5 is 125. Is 125. So I'm just kind of trying to combine some of these so it makes the multiplication a little bit easier. You can certainly just walk right down the list here. 2 times 2 is 4, times 3 is 12, times 3, times 3, times 3, and so forth. But we're just trying to simplify it the easiest way possible. 12 times 9 would be 108, right? So we have 108 now, times 3 times 125. All right, so let's do some of that over to the side here. We have 108 times 3, which is going to give us 324. right? And then we will have 324 times 125. Hope I have room over here. 20, 10, 12, 15, 16, 8, 4, and 6. And then we have, what do we have here? 4, 2, and 3, if I can fit them. Okay, so we have 0, 10, and 15, 10, and 4. So we end up with 40,500. 40,500. Where will we? We'll write that over here. So the greatest common multiple is 40,500. That is a nasty number. But imagine trying to find that greatest common multiple using the old method. I mean, we would have had to take 500 and keep multiplying it out until we hit 40,500 and 15 until we hit 40,500. It would have been a mess. It would have been taken a very long time. So this is definitely the easier route to take when finding the greatest common multiple. All right. Excellent. Let's talk about the next one here. So we have an 8, 15, and 100. How are we going to find the greatest common multiple? Well, let's factor all of them out. So we'll go back to our blue. If we factor this out, we have a 2 and a 4, 2 and a 2, and this is going to be a 3 and a 5. The 100 is going to be a 2, which would give me a 50, a 2, which would give me a 25, and then we're back to a 5 and a 5. Okay, so we have, now we look at our factors, and we determine what numbers are being used as factors. Well, if we start with the lowest one, which is a 2, we have 3 2s in this one, which is the most out of any of them. So we will multiply 2 by itself 3 times. And then we have 3s. We do have a 3, only one of them. And then we have a 5, and this one has 1, this one has 2, so we're going to use the 2. And there we go. There's our product there. Let's multiply it all out. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And then we have 24 times this remaining 5 times 5, which is 25. So we have 24 times 25. So if we take 24 times 25, what do we end up with here? 8 and 4. So we end up with 600. So the greatest common multiple is going to be 600. So if we had a fraction or an addition problem with all these fractions, so let's say if we had 3/8 plus 7/15 plus 9/100, okay, we would have to find the greatest common denominator. And to do that, we would use the greatest common multiple, which we just found to be 600. So each one of these we would change to a denominator of 600, right? There's an application of when we would use this greatest common multiple. Of course, then we'd have to adjust the numerators, excuse me, and then we could add this. All right? Excellent. Let's try, well, we'll try 2 more. Go ahead and try this one on your own, and then we'll do it together and see how you did. All right. So, and by the way, all these problems that I've done so far, I believe, are right from the book. So I'm not just pulling these out of the thin air. We're getting these out of the book. All right. So let's try this out. Let's find our factors. This is, well, I guess I could start with the lowest one. We'll start with a 2. 2 would give me 15, and then I could have a 3 and a 5. Over here, 2 doesn't work. 3 works, though. 3 would be, what, 25? And then a 5 would work here. And then we have a 2 would work, which would give us 40. 2 again would give me 20. 2 again would give me 10. 2 again would give me 5. All right, so what numbers are we dealing with? Well, 2s. Let's start with that. The most 2s we see are in the last one, and there are 4 of them. So we're going to have 2 times 2 times 2 times 2. And then the most 3s we see are just 1. Both 30 and 75 have just 1 3 in there. So we're just going to use 1 3. And then we have 5s. Well, this one has 2 5s. Yeah, so the 75 has the most with 2. So we put those in there. All right, then we can multiply this out. So 2 times 2. And you know what? Maybe just for the fun of it, let's go the other way this time. 5 times 5 is 25. 25 times 3 is going to be 75, right? 75 times 2 is going to be 150. 150 times 2 again is going to be 300. 300 times 2 again is going to be 600. 600 times 2 again is going to be 1200. I think if I did that right, 1200 is the greatest common multiple. All right. Excellent. Let's go on to the next one. And again, why don't you pause the video and then we'll do it together. All right, so we have 560. We'll divide that out by 2, which is what, 280? Did I do that right? 2, 4, yeah. Yep, 280. We'll divide that out again, and we have 140. Divide it out again, we have a 70. Divided again by 2, we have 35. And then we have a 5 and a 7. Ooh, these are big numbers here. So 2 can go into this how many times? 2. Which is remainder of 1, which would be 9, which would be 4. 294 times. 2 can go into that again, which would be 1 and 4 and 7. This adds up to 12. 7 plus 4 is 11, plus 1 is 12. And remember, that's a rule to indicate that it's divisible by 3, because 12 is divisible by 3. So 3 can go into this number. 3 can go into 14 4 times, with remainder of 2, 27, 9. And then again, what have we got here? Now this one's going to be a 7. 7 times 7 is 49. Okay, now we move to the next one. 2 can go into this 625 times. 6, 7, 8, 13. So 3 can't, but 5 can, obviously. So what have we got? 5 can go into this 12, 21. I think that's 125 times. 5 can then go into this 5 times. No, yeah, 25, excuse me, 25 times. And 5 can go into 25 5 times. Okay. All right. So those were some bigger numbers there. Hopefully you didn't have any issues factoring those. Now let's work out our numbers here. What numbers are being used as factors? Well, we do have 2s. And in fact, we have a lot of 2s. We have 1, 2, 3, 4 2s in this one. That's the most out of any, so it'll be 4 2s. And then as far as 3s go, we have 1 3 in this one, and that's the only 3. So only 1 3. And then as far as 5 goes, we have 1 5 here, and we have 4 5s over here. Ooh, that's going to be fun. So 4 5s over here. And then we've also got a 7. We've got 2 7s in this one. And I think then we've got all of our numbers figured out. So now it's just a matter of multiplying this great big thing out. So where should we start? You can pick your side. You can intermix. You can do whatever you want here to multiply this out. I think I might even start from the right side. I don't know. The numbers get smaller as I work my way to the left, which makes it a little bit easier to do it in my head. So 7 times 7 is 49, and then 49 times 5. Okay, well, we have to take the 49 times the 5. It's going to be 45 is 24. So we have 200. So we have 7 times 5, just so I don't lose track here. Then we're going to multiply it by, another 5, which is going to be 25 is 22, 10 is 12, 1,225. Then we're going to multiply it by another 5, and we're going to get 25, 10 is 12, 10 is 11, 5, 6,125. Then we'll multiply it by our last 5, which is 25, is 10, is 12, is 5, is 6, and is 30. We're shooting up here. Now we multiply that by 3. Cross it out. 15, 7, 18, 1, and 9. And now we multiply by a bunch of 2s. Now here, let's just take 2 times 2 is 4, times 2 is 8, times 2 is 16. So we'll just multiply this by 16 and just get rid of all of these at once. I guess, that would have been a good idea. We should have done that maybe before. Would have made it easier. We could have gone 7 times 7 is 49, and then just taken these 5s. 5 times 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125, and maybe even just those 3. We could have multiplied by 125. It would have saved us a little multiplication here. So there is no right or wrong way to do it. Whatever you feel gets you to the answer quickest with the least amount of work, go ahead and do that. So we are now multiplying this by the 16 because that's all of our 2's. So 5 times 6 is 30, 42, 45, 48 is 52, 6 is 11, 54, 55. And we place our 0. So we have 5, 7, 8, 1, 9, 10, 10, 10, 7, 14. Wow. All right. So if I did all my multiplying right, the greatest common multiple is 1,470,000. That is a massive greatest common multiple. And I'll just double check my math here. Looking at the book, yes, that is correct. So we did the multiplication right. Whew. Okay, so there we have our greatest common multiple right there. Massive number. All right, so let's move on. Algebraic expressions. This is the second part of the lesson here. So what happens if we want to find the greatest common multiple between algebraic expressions? So we've talked about what you have to do if you have something like this, 1/3 plus 2/9. Well, you have to find the greatest common multiple to get the common denominators, right? Well, what happens if this is like a 3x and this is like a 9a? Okay, how do we find the greatest common denominator or the greatest common multiple between these two when we have variables involved? Well, it looks like it's going to be a little bit trickier, right? Well, it's actually not that tricky at all. We're pretty much doing the same thing that we did before. So let's just take a problem and work this out. And I think you'll see that it's not very complicated. It's the exact same process that we did before. So before we took the numbers and we decided, okay, what are the factors of the numbers? Here we are going to do the exact same thing. So nothing really different here. The coefficient is going to be done the same way that we've always done it. Just factor that out, and we get a 3 and a 5. Now, this is where we get a little bit interesting. This c to the third and x to the fourth. Well, what are the factors for those? Well, here, I'll just write the factors for this number here. So we have 3 times 5 times the c to the third. We could factor that into a bunch of c's. It could be written as c times c times c, right? 3 c's would give me c to the third. I could do the same thing for the x's. I could make that into 4 x's being multiplied by each other. Okay, and that's really the factorization of this whole term. We factored the coefficient, the 15 in this case. We factored the c3 into 3 c's and the x to the fourth to 4 x's. Okay, if we wanted to factor this one, well, obviously 5 is already factored. That's already prime. C is already prime. It's to the power of 1. And then x squared, we could write that as x times x. All right, so here we have the factorization of the first term as well as the second term. Now we take it to that next step and we just ask ourselves what numbers, in this case, what numbers or variables are we dealing with? So if we're looking at all the factors, we can say, oh, well, we have 3's and 5's. That's what we're dealing with. We're also dealing with c's and x's. So let's take those 3's. So maybe I'll just write that. 3's, 5's, c's, and x's. That is what are being used for both of these terms. So if we take the 3, well, how often is 3 being used? The most it's being used is once in this first term. So that is going to be the first factor of our greatest common multiple. All right. 5. Well, the most 5 is being used is really once. It's the same in both. So we're going to take 1, 5. And now we have to move on to the variables, which is the new part, c's. And we do it the same way. We say, how many times was c used? Well, here it was used 3 times, and here it was only used once. We're going to take the greatest number of times that it was used in one term. So we have 3 of them, 3 c's. So it's going to be c times c times c. All right. X's. The most X's we used was, again, in this first term. We used 4 of them. So we're going to use 4 X's here. Okay. And then we're done. We've now pulled out the greatest number that have been used in both terms for all of these factors. And we are now ready to multiply to find our greatest common multiple. So 3 times 5 is 15. And then we have c's to the third and x's to the fourth. So the greatest common factor is actually 15c to the third, x to the fourth, which is actually the first term. And all that means is that this term here can be multiplied by something to get us to this 15c to the third, x to the fourth. And if you think about it, that something would just be a 3c squared, x squared, right? Because 5 times 3 would give us 15. C times c squared would give us c to the third. X squared times x squared would give us x to the fourth. So we can see that 5cx squared can go into 15c to the c cubed x to the fourth. And so, of course, can the first term. It's the same thing. It can go into it once. All right. So this is our greatest common multiple right here. Greatest common multiple. Okay? Very good. Let's try these ones. Why don't you pause the video and try it by yourself first? Okay, so if we factor these, we will start by factoring the coefficients. And that's going to be a 2 and a 2 and a 2, right? So we're going to have 2 times 2 times 2. And then, of course, we have 3 x's. And we have 2 y's. Okay, and in this term, we have a 2 times 5, right? I'm just doing that in my head. 2, 5 times x 5 times. Okay, and then we have just one lonely y on the end. So what numbers or letters are we dealing with? We're dealing with 2's, we're dealing with 5's, we're dealing with x's, and we're dealing with y's. So what's the most 2's? Well, there's 3. So we have 3 2's. What are the most x's, or excuse me, the most 5's? Only 1. And the most x's? Oh, that looks like a y. That's awful. Let me fix that. There. Okay, so the most x's, we have 3. 1, 2, 3. Oh, actually, what am I saying? We have 3 here, but over here we have 1, 2, 3, 4, 5. So we have 5 x's. Okay, so we have 5 x's. And then how many y's do we have? Well, we've got 1 over here. We've got 2 over here. So we're going to use the 2. Okay, now we're ready to multiply. So 2 times 2 is 4 times 2 is 8. 8 times 5 is 40. We have the 5 x's, x to the fifth, and the 2 y's, y to the second. That is our greatest common multiple. Okay? Excellent. We will try these, and then, we'll try these, and then that will conclude the lesson. So why don't you pause the video? We'll do this last one together, and then we'll stop there. Okay, so let's find the greatest common multiple. Start with the 3's, or the coefficients. So the 3 factored is just a 3. And maybe I'll just instead of writing these out, let's just try to take a little bit of a shortcut here. I'm just going to write these variables out the way they are instead of factoring them all the way through. All right. And then over here, my factors are going to be 2, 6, 2, and 3. So it's 2 times 2 times 3. And again, I'm just going to write these variables the way they are. It'll make sense here in a minute, hopefully. Okay, now, what are we dealing with? We're dealing with 2's. We're dealing with 3's. We're dealing with x's and y's and m's and z's. I think that's it. So we have all kinds of things to look at here. So what's the most number of 2's? Well, twice over here. So we have 2 times 2. Okay. What's the most number of 3's? We did the 2's. 1, 3. So we'll put the 1, 3. What's the most number of x's? Now, here, I'm just going to kind of look at the exponents. That's why I did it this way. I didn't have to write as much. So I have x squared. That's the equivalent of, having those two x's being multiplied by each other. And I have 4 of them being multiplied over here. So I'm going to take an x to the 4th. Okay, the larger of the two. And then the y's. Well, I have y to the 3rd, and then I have y to the 1. So I'm going to take y to the 3rd. And then I have m to the 4th, and I have m to the 5th. I'm going to take m to the 5th. And then I have z to the 12th and z to the 14th. I'm going to take z to the 14th. And now I'm ready to multiply. 2 times 2 is 4 times 3 is 12. And we end up with 12x to the 4th, y to the 3rd, m to the 5th, z to the 14th. That is going to be my greatest common multiple. All right? Very good. And I think that's where we will stop today. So hopefully that all made sense to you. The steps are very easy when you're trying to find the greatest common multiple. You just need to factor them, take the greatest number of each kind, and multiply it together. Okay? Excellent. Now, one other thought. Just make sure you don't confuse the greatest common multiple with the greatest common factor. Okay? I find that a lot of people over time get these two confused. Remember, the greatest common factor, you're looking for the greatest number that can actually go into. Oh my goodness. That is a typo. Have I been doing that this whole time? This should be the least common multiple. Oh my. Did I? I certainly did. Well, I am going to have to totally correct myself here. I don't know what I was thinking. All of these greatest common multiples, it should be the least common multiple. Hopefully you caught that as I was going through this lesson. All of these should be the least common multiple. We're looking for the smallest multiple that is common, not the greatest. So there you go. I just did what I told you not to do. Don't confuse greatest common factor with least common multiple. So all of these should be the least common multiple, not the greatest common multiple. And the least common multiple, again, so that you don't get confused, the least common multiple is the answer to a multiplication problem. So it's always going to be as big or bigger than any one term in the numbers that you've chosen. So if I have 3 and 6 and I'm trying to find the least common multiple, it's going to be the 6. Okay, it's going to be at least as big as the biggest number here. All right, often it'll be bigger. So if I have a 3 and a 4 and I'm finding the least common multiple, that's going to be 12. Okay, which is obviously much bigger than 3 or 4. All right, if you're looking for greatest common factors, there you're looking for the factors inside each of these, all right, that are common. So the greatest common factor for a 3 and a 6 is going to be a 3. Okay, that's the greatest common factor. This is the least common multiple. All right, the greatest common factor is almost always going to be smaller than any of the numbers that you're dealing with. Sometimes, well, it actually will be smaller than at least one of them for sure. So it's always going to be smaller than the greatest number that you have listed right here. Okay, so greatest common factor are the factors that you would use to get these numbers. Lowest common multiples are using these numbers as a factor to get larger products, to get larger numbers. All right, so you're kind of taking what is being used to make these for the greatest common factors, and you're using these to make something else in the least common multiples. So hopefully that kind of makes sense. And as you do these, hopefully it'll start to kind of sink into the brain a little bit more. But don't get these two confused. The greatest common factor and the least common multiple. All right, well, we'll stop here today, and I will see you tomorrow.